now let's look into the mode in detail. So it may not be it may not be at the center of a distribution. Sometimes the data distribution on the data might be like which you can see on the screen. So which that you see on the screen is known as bimodal. The data distribution on the bottom is bimodal, so even statistics can have some open-minded can be even statistics can be open-minded. So this is what we call it as a bimodal, and this is how it looks. The bimodal data, this is how it looks. So now if you see the mode, so it may give you the most likely experience rather than the typical or central experience. If you see the mode will give you the most likely experience rather than the typical or central experience. In a symmetrical distribution, in a symmetric distribution, the mean, the median, and the mode are the same that you can see on the screen. In skewed distribution, the mean and the median lie further toward the skew than the mode. So that's the reason mode will give you the better and the better representation when it comes to the skewed data. We said a median first. Now mode will take over median when it comes to the skewed data, whereas symmetric data all are same. That's median, mean, mode. Let's take one example which consists of all three. Yep, this is a height in centimeter. So you can see this, the mean and the median is by and large same. Now let me look into it. This is a symmetrically distributed data that you can see on screen. So now what I'm gonna do is I'm gonna try to find out the mode of it. So the mode is 170. Obviously, that's what I was telling. If the data is symmetric, the mean, median, and mode all are would be same. By and large, they remain same. So here, that's what the representation says: mean, median, mode. So whatever data that I have taken, it's not the created data; it's the real world data. That's the soccer players' data of 2015, and this is what the result. The data is by nature it's symmetric, and the data, the mean and the median and mode of the data set is by and large similar. Now let's go for the symmetric data which has a huge symmetry. So yeah, this is what the experience, and here let me see, the mean is 4.1025 years and the median is 3.0. Now let me try to find out the work experience with the mode. It's a 1. Of course, 1 is further towards your skew. If you see that 4.1025 is farther from the skew, and then 3.0 is little lesser than it's farther from the skew, but it's in between the mean and then mode. So when it comes to the mode is towards the skewness. So that's the reason the mode represents, or the mode represents the true picture of the skewed data set. Let me take one more example. This is also skewed. Let me see how it works here. Here it's annual income. So CS, annual income. Let me go for the mode. And here it is. It's a 9,000. 9,000. The second model is 50,000 USD. So obviously this data is skewed towards this side. So 25,000. Of course, here it is. So you got the two models. This is a bimodal. So one you will have a 9,000. So one it will be here. Yes, it's in between 0 to 25,000, and second one would be here, and then remaining one will by and large remains uniform. So that's what it's saying. It's a bimodal. It's a bimodal. Let me take one more time, and here let's try to find out what we're gonna get it. This representation is slightly different. Age and mode. Yes, it's a 31. You got only one. So 31, that's the age, and here you can see again, here also it's the 31. The mode is representing the central tendency of this data better than anything else. Mean is saying 48.96, and then median is saying 48 somewhere here, that whereas mode is saying here. So mode got captured the accurates because the mode has the highest around 20 to 40, around 30 to 40. We have the most of the entities has the age. So most of the entities are are aged between uh, uh, 30 and 40. So that's the reason the mode is capturing the true picture.